Let us understand this question. A bullet is given, which is moving with some speed. Speed is given here, and mass is also given. Now it penetrates a fixed target, like this I have shown here in this figure, and it offers a force of 1000 Newton. We are asked find the initial kinetic energy. B, we are asked when it will penetrate, it will stop somewhere. So we need to find that distance when it will stop. Let's say it is D. Then the speed with which the bullet emerges out, the speed with which the bullet will come out of the target if thickness is this much. So if thickness is this much, then how much the speed the bullet will be having. Let's say it stops here, but what if they are saying, like, say the thickness is only this much. So when it will penetrate, whole kinetic energy will not be lost. So it will come out, emerge out with some speed. So that speed they are asking. So there are three parts of this question. Let's do one by one. First thing, we need to calculate kinetic energy. We will use the formula half mv square, and then we will get it 625 joules. We have to convert mass into kilograms and calculate this. Okay, so it was having energy of 625 joules here. Now let's do the B part. When it will come to rest, how much distance it will travel within this fixed target. Now understand question. As bullet penetrates, force of force of 1000 Newton works on it in the opposite direction of the motion. And we can use the work energy theorem here. See what is happening is, as soon as this bullet, let's say this is a bullet. So as soon as this bullet is coming like this with 625 joules of energy, when it comes here, this force, resisting force, start acting on it, and it will act until the whole energy 625 joules is getting consumed. So that is the logic. So that's why the work done by this force will be equal to the change in kinetic energy. And we are saying we have to calculate before coming to rest. So we also know the final kinetic energy. What we want is at rest, that is zero. So we can apply the kinetic energy theorem here. So we have applied here, and as the bullet eventually stopped, final kinetic energy will be zero because V will be zero, and work done is change in kinetic energy. Zero is the final kinetic energy minus 625 joules, and 625 joules of negative work we need to do. Intuitively, we also would have thought it like it is having 625 joules of energy. It is coming here now to stop it. How much work we need to do, or how much energy we need to remove? We need to remove exactly the same magnitude of energy. So we will do the negative work to slow it down and make it finally at rest. When it is at rest, all of the kinetic energy, all of the initial kinetic energy which we calculated, that will comes to zero, or the negative work is happening. We have removed that much energy from the bullet. Now let's do the last, this one, how the second part of it, the distance through which the bullet has penetrated. Let's calculate that. Okay. So work done, we know we have to do like this much minus 625 joules. Now let's do. So this much work force was acting, and this much distance it will act on. This distance we don't know, but we know the work done. So work done is equal to force into distance. This is 180 degree, so that will be minus 1. So we will get minus 1000 d. We are solving for this distance, and we will get the final answer as 0.625 meter. So it goes 0.625 meter, and then this bullet eventually stops. Now let's come to the last portion. What if it is 0.5 meter? Like we were telling, what if it is lesser than that? Then all the work done is not done to remove all the energy. There will be some remaining kinetic energy, and we can calculate that also because the distance is given now. So this force will only act only till this distance. So how much energy it can remove? Let's calculate that. If the distance is half a meter, it is lesser than its stopping distance, which is this, right? Zero point 0.5, zero point 0.6. So there will be some kinetic energy left, or bullet will have some speed. Work done on the bullet will not reduce the kinetic energy to zero. It will not reduce. There will be something remaining. So how much work we have done? We have done of negative 500 if we are only taking the distance from here till here, that is of half meter. So only this much work is done. The kinetic energy will be only reduced by this. So we were having energy of 625 joules. By the half meter thickness, we are able to reduce it by 500. So the remaining energy is 125 joules. So now the remaining kinetic energy, how to calculate how much speed it will have, we know the energy, we can calculate it by equating it with the formula of kinetic energy, half mv square. So we need to calculate that, and we will get the value of v under root 5 into 10 raised to the power square, 10 raised to the power 2, and we will get it 223.6 meter per second. So remember, it was going with 500. It was going with 500 of speed, and now see how much it is remaining. 223 only remaining. So here just I have written some values of square roots. If you want to remember them, recall them, the values, because here to calculate that was necessary. So it emerges out with this speed. And let's go to the next question. This is a formula based question, question number 12. The kinetic energy of a body we need to calculate. Mass is given and the momentum is given. So you should know the relation between kinetic energy and momentum. It is very simple to drive also. We should know each formula. This is the formula for kinetic energy. This is the formula for uh, momentum. So we'll replace like P by M. We can take this side and replace this V, and we'll get a relation between kinetic energy and this one. And the formula is Ke is equal to half P square by M. Now we can use what is the information given. The mass is given, so we can put m here. Mass is given as 0.1 kg and momentum is given here. So we'll calculate the kinetic energy. So it's just a simple calculation. The answer you will get is 2000 joules.